Hi everyone, welcome back to the Internet Report, where we uncover what's working and what's breaking on the internet, and why. This week, we're talking about stealth outages, disruptions that aren't always obvious and can be tricky to detect. We'll cover recent disruptions to services at Slack, Microsoft 365 and X, and we'll also keep you up to date with the latest global outage figures. I'm Barry Collins, and I'll be hosting today with the amazing Mike Hicks, Principal Solutions Analyst at Cisco ThousandEyes. As always, we've included chapters in the episode descriptions below, so you can skip ahead to the sections that are most interesting to you. And if you haven't already, we'd love you to take a moment to give us a follow over at Spotify, Apple Podcasts, or wherever you like to listen. Productivity platform Slack experienced intermittent issues on May the 12th. What was the cause of this outage, Mike?
So Slack is a collaboration platform, basically, primarily used for sort of messaging and really sort of keeping that communication going between sort of workplaces, but also linking it to projects themselves. So they experienced this disruption or this outage that sort of affected people globally. It's kind of interesting in itself because of the way it sort of manifested. So Slack actually acknowledged the problem themselves around sort of 2236, but we'd sort of seen it previously to that. There was no specific pattern itself, except we could see global disruption. So what I mean by that was we couldn't see any particular sort of CDNs or any particular geographic location around the world sort of being impacted. And the reason I say that as well is you have to think about what Slack is doing from an application perspective. So because we're doing real-time communications, we have to effectively sort of communicate with the back-end service depending on where those messages are going. It's a real-time application from interaction perspective. And this wasn't a lights on, lights off type of situation. So that didn't mean that somebody pulled the plug and we lost a complete application. When we actually looked at it, we could almost see this pattern occurring where you could sort of see load coming in. So this kind of sort of, we may be looking at some sort of load, some sort of routing problem, but it was specific to the back end. So there was no systemic network issues that were occurring that we could see around the whole area. We actually started to look into the back end. We started to see some 500 errors. So these are internal server errors. I will say these are effectively catch-all errors. So these are when the front-end service responding that is tried to get information and it couldn't actually work with the information it was getting back from there. Now, from our perspective, is what that tells us is that we're getting in a response itself. So we actually been able to communicate with the system. So we're authenticating, we're logging on, but we can't get this back-end service responding to us. So I said, this kind of gives us a little bit of indication to what's occurring. So I say, so we know now it's not in the network, we know it's in the application itself, we know it's with that communicating with the back-end services themselves. The common causes for these types of, where we see these 500 errors, could be like a misconfiguration, it could be some error in the website's code itself, or it could be some database connection. Remember, what we're talking about from a Slack perspective is this interaction with the back-end system. Now, Slack actually identified the cause as being an issue with the communication link between the application itself, so that front-end web application, and the database routing layer. So that's consistent with what we saw and the reason why we saw these sort of 500 errors coming back there. Slack actually sort of put some remedial actions into place around 11:35 p.m. UTC, and sort of around 11:40, all the connectivity was improved from most regions. Sort of saw some blips afterwards, and then Slack declared everything resolved around 11:58 p.m. UTC.
Intermittent outages can be hard for IT ops teams to detect. Tell us more about these and other types of stealth outages and why they're important to catch.
So we talk about a stealth outage. What we're talking about is essentially something that went undetected. And when we talk about this Slack one, if we actually saw how it manifested itself, if I was to log on to the systems, I said I could actually authenticate, I could log on, and for all intents and purposes, it looked like it was operating. Everything was there, and if I was actually going to send a message, I was unable to send it, but I wouldn't have known unless I was trying to interact with the system at that time. So it wasn't any error message coming up on the screen, so everything looked like it was actually connecting itself. On top of that was this intermittent nature. Where we had this situation with the back-end routing, that then caused this intermittent, because sometimes we were actually making a connection, sometimes we weren't, so it's intermittent nature. When we talk about a stealth outage, it's one that we don't really know that's happening, but could effectively sort of have this devastating impact. If we're talking specifically in this environment, it meant that we weren't able to send a message. But if it was linked to a project that had some sort of output to it, you could start to see that. If we think about this in something such as a payment processing system, so where we have an intermittent outage itself, where somebody's actually performed the transaction, but because of the different third-party systems in the back end, you could actually have a failure at one point or one function of that. So the transaction goes through, but for some reason, the payment isn't actually receipted or the payment isn't actually made from the purchaser to the vendor in the back end there. But it's gone through, it's ticked, the green lights come up, everything says it's okay, and we've sort of been able to walk away. And if you sort of then manifest that up into sort of a bigger problem, if you're thinking about where we have these systems interacting, and if it looks like all the lights are on and these one systems that are going there, you have a failure in one part of it and you were unaware of it. You're waiting for a system or an alert to come up to tell you it, but it never occurs because, like I said, it doesn't get the signal coming through or it doesn't have this symptom. So if I'm looking at the front end, and even if I'm looking at individual status pages, I don't actually see any issue occurring.
Can you share any tips on how to catch these stealth outages?
So again, we've talked about this stealth outages. One, I don't know is occurring, right? So this is something you sort of need to be aware of to start with. So I don't know it's happening. So everything on the surface itself actually looks good. So the first thing to do is actually let's establish a baseline of all these components that are included in this system, and therefore then understand what state of each of those systems have to be in for it to be operational. It doesn't essentially matter what it is. Could be talking about performance level. We could be talking about getting an assertion code back. So I expect every time to get a 200 from an HTTP perspective, or I expect to get a 400, because what I'm actually doing is trying to do these credentials. If that changes, I need to know about it. The point is that these states right through my service delivery chain for all these components are at a known level. I know when all of these are, I'm receiving this 200, okay, I've got that at 5 milliseconds, I've got this response coming back at 20 seconds. I know when they all line up, then everything is good and everything's wrong there. If I get a deviation in one of those, I want to know, because it could be that we're actually some sort of functional failure or we start to have this issue occurring. Now, the other part to this is this always-on testing. My classic example I was using this is we go back to the good old days of the telephone on a desktop. If I pick up that telephone, I expect to have a dial tone. It's no good picking it up and there's no dial tone because I, at that point, cannot make a call to report the fault on that system. So what the telephone system developed was this always-on test where they're sort of sending this pulse out. Now, effectively, this is what we're talking about here, but we're doing it across a complete service delivery chain. We're sending synthetic tests, proactively sending these tests across there to emulate user interactions. How would I work for my entire journey through the service delivery chain, through the process itself, so that I get the response coming back? And this is where I'm looking at each of those states. The reason you do that, like I say, is that if I'm relying on real user traffic alone to do that, I'm not only going to know as a fault when one occurs. What I need to understand is there an issue occurring beforehand? So before someone makes a transaction, before someone goes to send a message, I know that system's fully up and operational. And the sooner I can identify that there is some sort of breakdown within that service delivery chain, that I can actually either kick off some automated process to recover that, or I can take sort of mitigating action to make sure that the user impact is lessened.
Microsoft 365 also experienced intermittent issues recently. What happened there, Mike?
It's impacted Microsoft 365 services, including Teams and Outlook Online. Now, the incident was actually acknowledged by Microsoft themselves, which kind of makes things a little bit easier because we sort of saw this happening. Now, what we actually saw when we looked into this was primarily impacting sort of North American users. This helps us, again, identifying what's happening. So then when we actually looked at the path getting to these, again, you saw no network issues or no systemic network issues. There was sort of minor or nothing that coincided that could be attributing to impacting these services. But the connectivity we saw was all going through the Azure front door. So with that connectivity there, then this is where we're connecting to a local service and then sort of route from where we are. So this is then we're seeing this is impacting primarily these North American users or the areas around there. Again, we're looking at something in that forwarding data into the back-end services themselves. Intermittent problem again, indicating that it's routing. So we saw some connectivity, then you see the connectivity drop. So some traffic was getting through, some wasn't getting through. And effectively, this would have manifested itself as sort of laggy. Some people wouldn't have been able to log on, but then they try again, they could have actually got on or send a message and they would have got on that point then.
Can you explain the purpose of Azure Front Door and what went wrong with it in this instance?
So Azure Front Door is this cloud-based service, and it is what it says. The label actually occupies the front door into these Azure services there. But it's essentially a global load balancer. So it's there to sort of enhance the application delivery, the speed, and sort of reliability of connection. So it uses layer 7 load balancing to manage traffic across various regions and endpoints. Now, each one isn't specifically restricted to an Azure region, which means that it is truly this global access point, is a global load balancer. So what happens is when you actually make your connection, you're going to go to your local one, because the whole point is to reduce that geographical distance so we can then, so that Microsoft can take care of where it's routing you into the relevant instance in the back end or the relevant service in the back end there. In this particular case, what was occurring was, and was confirmed by Microsoft, that there was some sort of misconfiguration within the routing setup for the Azure front door. What was happening was effectively we're sort of starting these load issues building up. So you sort of see this, we couldn't forward the traffic. Now, again, there's sometimes see these clues of when it starts to come out. So to mitigate this problem, what we could see was sort of traffic being routed to other services themselves. So normally if I was connecting from North America, I would expect to go into a North American resource there. But I was actually seeing in some instances, for example, I was being routed into Europe. That's the beauty of this system, is that because it is load balancing, I'm able to distribute to a healthy point, which allowed them to sort of rectify what they're doing before they then were able to roll it back and sort of make sure then everyone was going. So connectivity was maintained, but we're sort of routing traffic around the problem area.
Continuing our theme of stealth disruptions, users of the social media platform X experienced intermittent issues starting on May the 8th. What did we see this time, Mike?
So the users themselves were reporting a functional issue. So there was an issue specifically with the notifications, so the badges and understanding what was going on. It's actually unclear if sort of other functions were affected or impacted by this as well. But when we actually looked to our tests, so to understand what was happening, we could again see there was no network connectivity issues, and the issues were primarily in the back-end services. So the connectivity, I say, remained sort of intact. Now, when I actually look specifically into some of these tests, it's very difficult to define this function itself without having something that's going and logging on, sending a message to sort of test every part of it. So what we actually want to do is just to try and isolate down to that fault domain. So there were some sort of breadcrumbs that we could see. So we sort of saw some timeouts when we're actually trying to retrieve bits of information. And sometimes we were going into sort of a loop. So this is where you have a redirect where you're sort of going back to yourself, or it just doesn't go anywhere. So it times out because of the application itself sort of built into that. So sort of various symptoms in this back end, which would have been indicative of a back end service problem and match the symptoms the users are actually reporting themselves. Again, intermittent. So this wasn't all the time. So you sort of saw this dropping up, dropping down, or blips in connectivity. So from a user perspective, although they're reporting these, unless they're specifically using that function at that time, and it may have been they could just try it again and it was there. So this is why it manifests itself in notifications, because notifications is a push, right? So I'd expect them to go there, and I'd expect to be a notification. I hadn't had any for a while, for example. So then I'd actually query what was going on and report that there. But any other thing, I'd have tried it because I'm pulling that information, and I'd have actually tried the connectivity. It may have failed, and then I tried again. It went through. So it must have been my end, where we continually press the key harder and harder till it goes through. So it could have been something like that.
Thanks for the deep dive into those disruptions, Mike. And now let's turn to the overall outage trends. Both globally and in the US, outage numbers increased during the past fortnight. Tell us more about what you're seeing there, Mike.
The upward trend in global outages that we've observed since mid-April continued over these past 2 weeks, with outages increasing noticeably from May the 5th to May the 18th. In the first week of this period, which is May the 5th to the 11th, what we saw was 11% rise, which was an increase from 444 to 495. So this trend persisted into the following week, which was May the 12th to the 18th, when outage rose another 8%, which saw numbers jump from 495 to 536.
Recently, we've seen a significant decrease in the percentage of network outages that originate in the US. Any thoughts on why that might be?
So from May the 5th to the May 18th, the United States accounted for an average of 24% of all network outages. Now, this was an increase on the previous period, which was 21%. And that period was April 21st to May the 4th. So this 24% marks the third consecutive period in which the US-based outages constituted less than 40% of all observed outages. So when we think about the outages, we're actually seeing a number of things. So we're looking at a total number of global outages. And if something sort of occurs outside the region, so in this particular time, some of the US carriers were doing sort of work in areas outside of the United States. So on their networks infrastructure, say within London or within Europe itself. Now, we saw some of these outages were very concentrated, although they're on US carriers, to these locations. And then what also can occur over this period is, because it's sort of a downtime effectively within these other areas, other regions can sort of pick up. So for this particular period, we actually saw an increase in work in the APJC region. So this there has this effect of sort of skewing the results. So although there is a number of outages taking place in the US, we continue to see this upward trend in terms of outages occurring there. There is more outages occurring outside of region itself. And now we've actually moved on where these areas are fairly localized, i.e. if they're making a change or the maintenance, or even from a failure perspective, they're able to sort of localize the footprint so we don't have this domino effect. Therefore, we don't see it spread around there. So this then allows these outages to take place in other regions to effectively not have this filtered down impact and vice versa. So therefore, we start to see this decrease within this area here. But it is kind of interesting because this goes against the trend we saw last year. Now, whether this was specifically we'd like to see an increase, like I say, within APJC region for this particular period, whether that continues going forward will be interesting to see. All through 2024, we sat around that 40% or greater mark for pretty much the entirety of 2024, whereas this time we've actually dropped down to say for 3 consecutive periods.
And that's our show. Please give us a follow and leave us a review on your favourite podcast platform. We really appreciate it. And not only does this ensure you're in the know when a new episode's published, it also helps us to shape the show for you. You can follow us on LinkedIn or X at ThousandEyes, or send questions and feedback to internetreport@thousandeyes.com. Until next time, goodbye.